Let's look at another problem. This problem says that a right cone has a slant height of 6, as shown in the figure below. So we have a picture already drawn for us, which is nice. Write the volume of the cone as a function of one variable. So we're going to get it down to r. They're already telling us what to get it down to. Then it asks, what are the dimensions? So eventually we need to get the radius and the height that maximize the volume of the cone. So looking at this problem, we know that we're going to use the volume. That's what we'll take the derivative of eventually. So the volume of a cone they've given us, 1/3 pi r squared h is what we're going to take the derivative of and find maximum and do all that stuff. So we need to look at the constraint. The thing that they have given us is slant height. Slant height is out here on the side. So when we're looking at this, what we see is a right triangle. And our relationship for right triangles is the Pythagorean theorem. So what we're going to use is that r squared plus h squared is going to be equal to 6 squared. So that means we have r squared plus h squared equals 36. And they've already told us we need to get this in terms of r, which means we need to eliminate h. So we need to solve for h. So this is our constraint. This is what's going to help us. So subtract r squared. So h squared is equal to 36 minus r squared. And then we have to take the square root. So h is equal to the square root of 36 minus r squared. Then we can bring that up here. So our volume, all in terms of r, will be 1/3 pi r squared, and h will now be the square root of 36 minus r squared. So we have answered the first part of this problem, right? The volume of cone is a function of one variable r. Check. Now the second question is, what are the dimensions that maximize the volume of the cone? Which means we have to take the derivative. So bear with me, this derivative will be long, but we'll get through it and we'll get a sensible answer. So to take the derivative, we have v prime equals 1/3 and pi are just numbers. So I'm going to pull those out front and not worry about them for now because they're just going to be multiplied by my derivative. My derivative will be the first, which is r squared, because this is a product, times the derivative of the second. So remember, a square root is the same thing as a 1/2 power. So I have times, bring the 1/2 down, 36 minus r squared to the negative 1/2. And I have to use the chain rule because it's not just a square root, it's a square root of things that are on the inside. So I have to take the derivative of 36 minus r squared, which is negative 2r. And that is the first part of my product rule. So I'm going to add the second part, which is the second square root of 36 minus r squared times the derivative of the first. The first is here, is 2r. And there we go. We've taken the derivative and simplifying this down so that we can solve for r is going to be our next big step. So let's do that. Let's take this, v prime is equal to, let's leave the 1/3 pi out front because it's still just a number. And let's rewrite this. We're going to have 2r, negative 2r times r squared on top. So that's negative 2r cubed over 1/2. So 1 is on top, 1 multiplying by 1 doesn't change anything, 2 is on the bottom. We have a negative 1/2 so that it is a bottom square root of 36 minus r squared. That's that one. And then this one is just plus 2r square root of 36 minus r squared. And there we go. A couple things can happen. One, there are two 2's over here. Those can cancel. Two, we need to combine these to be able to solve for r. So, oh, I didn't mean to write an r. That's an over 1. This is over 1. We need them to have the same denominator. So this has a denominator of the square root of 36 minus r squared. So I need this one to have a denominator of the square root of 36 minus r squared. What I do to the top, I have to do to the bottom, 36 minus r squared. So this will become, leave the numbers out front, v prime is 1/3 pi. I have negative r cubed plus 2r times the square root of 36 minus r squared times the square root of 36 minus r squared is a whole 36 minus r squared. All over, they have the same denominator, so that is my denominator I'm going to write. 36 minus r squared. Okay, now we can distribute. That will be 36 times 2, 72, r minus 2r cubed. So when I combine these, my derivative, it still has a number out front, times negative r cubed minus 2r cubed is negative 3r cubed plus 72r all over my denominator, the square root of 36 minus r squared. So what I did was combine like terms. This became this, and then I added them together and got this. So here's my derivative. There are a couple things that we need to set up. We need to set up a reasonable number for what we want r to be. We know that r cannot be negative. So r is going to be bigger than 0. And there's something that it cannot be larger than. If you look at the denominator here, we cannot take the square root of a negative. So we don't want this to be negative or equal to 0. So if we take the square root of 36 minus r squared, we want it to be greater than or equal to 0. So that means we want what's underneath to be greater than or equal to 0. So if we take 36 plus r squared equal to 0, minus r squared is my equation, so let's fix that. Subtract or add r, so we have r squared equals 36. R is plus or minus 6. Technically, these are two critical points, but we know that we cannot have a negative measurement, so that takes out the negative 6. And when we plug in 6, we will get a 0. Anything over 6, if we plug in 7, that's 36 minus 49, which is a negative number, which cannot happen. So we know that our upper bound for the radius is 6. So we just need to find that middle number to figure out if that's our maximum or minimum. So we take the top here and set that equal to 0 to get our other critical number, plus 72r equal to 0. So you can factor. If you factor out an r, you can factor out a 3r and have negative r squared plus 24. So r is going to be equal to 0, and here we'll do negative r squared plus 24 equal to 0. Add r squared, 24 equals r squared. So r is plus or minus the square root of 24. And again, we cannot have the negative one, so we are only going to look at the positive square root of 24. We got r equals 0 as a critical number, but we know that the radius cannot be 0 because then I wouldn't even have anything to work with. So the only number that I'm looking at is a positive square root of 24, which, by the way, is about 4.9-ish. So if we want to choose two numbers, we need to figure out if this is and we are looking for a maximum for the volume. So let's check some numbers. Smaller than 4, we can check 1. Larger than 4, we can check 5. When you plug in 1 to the derivative, use your calculator, get some stuff, you will get a, positive. And when you plug in 5 to the derivative, you plug that in, do all that crazy stuff, you will get a negative. So we have gone from increasing to decreasing. That is indeed a maximum. So the square root of 24 works out for me. So my radius is the square root of 24. And I don't have any units. Notice I was just given a number 6, so I don't have any units to use here. Now I need to figure out height. So I'm going to use this equation. Height is the square root of 36 minus r squared. So height is the square root of 36 minus r is now the square root of 24 squared. So height is the square root of 36 minus 24, which is the square root of 12. So there's my height, there's my radius, and that's my problem.